Meanwhile, you guys can go on our website and watch those previous videos if you want to cover the theory part also. If anyone have any doubt regarding this, they can speak now. Anyone have any doubt or query regarding this?
Sir, what was your question? Can you repeat it?
No, there was not any question. I was just telling all of you that topics like LED blinking, which we covered in last class, and multiple toggling multiple LEDs, along with controlling LED with switches, UART, SPI, I2C. These basic things were already covered in our previous course. However, I'll cover the practical parts here. But meanwhile, if anyone wants to learn the theory part or want to learn all those things in a detailed manner, they can go to our website and watch those videos also, and I can solve their queries here. So if anyone have any query regarding that part, you can speak now. I think no one have any doubt or query regarding that. Am I clear?
Yes, sir. Yes, sir.
Okay, perfect. So just go to our website and watch those videos. And at any point, if you feel any doubt or query, almost all those queries were solved in that classes also. You can watch it. But apart from that, if there is any query or doubt in your mind regarding those topics, you can speak in our live classes. You can ask them. I'm more than happy to solve it. Okay.
Okay, sir.
Yeah, okay. So in our previous lecture, can anyone tell me what we covered?
We cover installation of STM32 and blink the LED at
Okay.
last class.
And we blinked our LED. And there was some task assigned by me to all of you. Remember?
Yes, sir.
Yeah, so what was that task?
Everyone should try on their board like blinking LED.
I had already given you the code of blinking one LED. The task was that you should try to blink all the 3 LEDs available on our board.
Sir, regarding that, actually, I am using the Nucleo H503 RP.
No problem.
No. On that board, there is only one LED where user can use.
Okay, so did you try blinking it using other delays? Like I showed you in previous class using a delay of 100 millisecond, I think.
Yeah, I tried, sir.
So I requested all of you that you should send the code in our group, but I received none. May I know the reason from everyone? Please turn on your mic and speak one by one. I just want to get the reason. There may be the reason that you guys don't have the board, but I only requested you that you should modify the code and send me. Please, one by one, everyone turn on your mic and just clarify the reason.
Sir, I complete your task, but I forgot to sharing this, so I can display my code now.
Okay, I'll display it right now. Oh, no issue. You can share the code in the group.
Okay, sir.
And Ajay,
Sir, actually, this was my first class. I was not on there on last week's class.
yeah, but its recording is already available.
Yes, sir. I haven't watched it because I haven't installed STM32 CubeIDE yet.
Okay,
I'm
just go
installing
through
it
the
on.
just
I'm
go through the last
installing.
lecture. You will be able to install it.
Okay, sir. Actually, I have some internet issues in my
Yeah,
town.
no issue. Just
That's why I plan to install it on next week. That's why I haven't watched that video, sir.
okay, okay. And Amol,
Yes, Chandan. I have completed for one LED because I have
no,
STM32 board.
for one LED, it's already done by my from my side in previous.
Yeah, yes. But I have nucleo boards, and there is only one user LED,
Which
and
nuclear board
other
you
one
are
is
using?
STM32 446 RE nucleo board.
Okay, so did you tried it by varying the delay?
Sorry.
Did you tried it by varying the delay?
Yes, I have tried actually.
But I received
In
no
my
code
state.
in the group.
Yeah, code that I forgot. Maybe I will share.
No, share it right now.
Okay.
It will take just 1 minute. You need to just copy and paste it.
Yes.
And Jivitha,
Hi Chandan, I couldn't download it STM32. I do have some issues with the laptop, and one more thing is I couldn't go through the last week whatever we completed the recording, and the third is totally I forgot about the action item. So yeah, by next week I'll do it again.
okay. At least you are being honest. That's okay. But things like this won't work. It will not be a course where only I will teach you guys. You need to give your 100% too. Like if
Yeah,
I'll
sure.
assign tasks, you guys at least try. I'm not saying you should complete it, but at least try.
Sure, Chandan. Actually,
Okay.
I was not aligned with the last class, so definitely I'll make sure for the next classes.
Okay. And K. Pravallika. I think she's not here. Murli.
Hi, sir.
Yeah. Hi.
Hi, sir. I faced some issue with my laptop, but today I installed that one. I tried that code, but there is no board with me, and I forgot to share in the group.
Okay, so everyone is having issue with their laptops. Correct. Fine.
Yes, sir.
Anyway.
Software is installed, but I'm unable to open that main.c file.
Okay.
Yes, sir.
Okay. And Tony Thomas.
Yes, sir. My board will be coming on Tuesday. That's why I not tried yet.
Yeah, which board you are taking?
STM32 Nucleo only.
Which Nucleo?
That
which series?
F4 is there.
Okay, but I just requested all of you to share the code.
That's I not tried. That's why I didn't post the code.
Okay, fine, everyone. So today We have already covered LED blinking topics, fine, and multiple LED and controlling LED with switches. These videos are already posted on our website. Just go there and watch those videos. Now we will cover new topic today, that is UART. Why I am the UART is already covered in previous module also, but why I am covering this once again is because everything that we are going to learn in this module, like GPS, GSM, and all things, and all the communication, all those communication will work on this protocol, on the UART protocol. And for that reason, and in your industry projects also, many things or many modules that you will use in your industrial projects, these things will work on UART, SPI, and I2C, but mostly on UART. For that reason, I am going to recap it once again, and so that we can initialize our GSM and GPS module with UART also. So today I am going to cover UART. Fine. So can anyone tell me what have you hear the word UART?
It's a serial
Yes.
communication, sir.
Okay.
It has a transmitter and receiver on both ends.
Okay. So UART means universal. UART is a protocol. Okay, it's a protocol which means universal asynchronous receiver and transmitter. Okay, why it's universal asynchronous, not synchronous, and all those things. What is why it's named like this? These things are covered in our lecture available on website. So theory parts is already there along with all the practical parts. I'll just cover the practical part here. And so UART is nothing. It's a universal asynchronous receiver transmitter. It's asynchronous because it does not use clock pins. So if you want to communicate between two boards or two modules, there must be something that will correlate with all those things. But in this case, we are not having any clock pins. For that reason, we are going to use baud rate. So the main reason why UART is asynchronous is that clock is not present here. And instead of clock, we use baud rate. What is baud rate?
Number of bits transmitted.
Per second.
Yeah. So number of bits that will be transmitted in 1 second, that's the baud rate of board. Universally, we use baud rate of UART like 9600 or 115200. But you can use any baud rate that will be supported by your module. I'll just now share my screen, open the STM32 CubeIDE, and generate one project using UART. So just let me know when my screen is visible. Is it visible?
Yes, sir.
Yes, sir.
Yes, sir.
This is the STM32 CubeIDE.
Yes, sir.
I'll open it. And my workspace was training, so I will use it, launch it. Okay, so this was our first project in which we blinked our LED. I'll just modify this project only for UART also. So this is my project explorer list. Can you see it? Can you guys see this?
Yes, sir. Yes, sir.
I'll just open it and move to the IOC file and open my IOC file. You can see it's getting opened. In previous lecture also, you guys have seen this view, pinout view and everything. Am I correct?
Yes.
So these were pins used for our GPIO. So I'll just remove it or I'll keep it as it is. Now, all these protocols like UART, SPI, I2C, these comes in this section. Like you can see system core here. I want from your side, so be fast.
Yeah, we are able to see.
Yeah. So in the system core, you will see all those things which we will use later. No need to use it right now. Analog also we don't need right now. Timers we will use later. Just move to this section, connectivity. In connectivity, you can see my board is having two I2C, one low power UART, one QSPI, two SPI, one UART. Fine, and one USB. So apart in all these connectivity things, which one we are going to use now? Can anyone tell me?
UART 1.
UART. Perfect. So in my board, it's written as UART 1. In your board, it might be written as UART 2, 3, 4, 5, anything. Just right click here and you can see this mode icon appears. In mode, click on this drop icon and select asynchronous. Why we are using asynchronous?
UART is a asynchronous protocol.
Yeah, in beginning of this topic, I already have mentioned it that UART is asynchronous protocol. So I have selected it as asynchronous. Now leave all these things as default. Now here, you can see as soon as I have enabled my UART in asynchronous mode, these two pins are already selected, PA9 and PA10.
Yes, sir. Select.
Okay. Now I'll move to the schematic part and verify whether these pins are available on my UART or controller or not. So STM32 WB55RG schematic, correct? This is already covered in our last class. Everyone can remember it, how we opened our schematic of
Yes, sir. Already downloaded.
Okay, perfect. Now here we will select Control F and use or UART. Fine. Can you see this?
Yes, sir.
Okay, I'll just zoom it in case anyone is having any doubt. So here you start to, but this is not what we are going to use. It's showing PA9. So I'll search here PA9. PA9. PA9 is here, but it's on IC, so we will not use it. Yeah, always. Whenever you will try to communicate or do any communication protocol coding, just make sure your connector should be on connector. Like in your UART, you can see in this schematic, you can see PA9 was available on U. U means IC, but we cannot connect IC pins manually. We always think we always have to think that we should connect connectors. Hatim, are you there?
Yes.
Yeah, so can you just show everyone your controller?
Okay.
Okay. Let me open the video.
No, no, just show them your yeah. Okay. So everyone can see the controller that the heart team is showing.
Yeah.
Yes, sir.
Okay. So in
Yes,
this
sir. Yes, sir.
section, you can see there are lines like a structure on both right and left side. Can you see it? Black
Yes.
lines.
Yes.
Yes. So these are connectors available on your board. You can see there are pins that are getting outside those connectors. Can you see it, everyone?
Yes. Yes.
Perfect.
Yes, sir. Yes, sir.
Thank you, Hatim. You can close your camera now.
Yes, sir.
Yeah, so we will always try that we should find our pins on connectors because we can use jumper wires and everything to connect on those connectors. So you can see here PA9 is on connector CN5.
Chandan, I think your screen is not visible.
Oh, sorry. 1 minute. Okay, now it's showing. Is my screen visible now?
Please off your mic.
Yes, visible now.
Upender? Yeah, thank you. Yeah, so here you can see this PA9 is on connector CN5. Everyone can see CN5.
Yes, sir.
And our other pin was on PA10. So now I'll search PA10 or you can find here. Yeah, here. Can you see this PA10? Everyone can see this PA10 on connector CN9.
Yes, sir.
Okay. So for this UART on my controller, I can use these two pins or there are multiple available pins to be used for one peripheral because what happened in your industrial project when you are going to use some you are going to use many protocols like in the same project you will be have to use UART protocol also or multiple UART like UART 1234 SPI I2C and in case your these two pins PA9 and PA10 gets occupied by some other protocol, then what you will do?
Maybe we have to change the pin.
Yeah, so in that case, I will try to find if my board is having any optional pin for same working. So what's the name of this PA9 pin?
UART TX.
UART1TX. So here in this search box, I'll search USART. Yeah, here you can see USART1TX. Can you see this?
Yes.
Yes, sir.
And as soon as I have written it,
Chandan, but why two pins are blinking?
because one PA9 is already for USART-TX.
Okay.
Here you can see PA9 is already for UART1TX. So it's getting blinked.
And the
optional pin is here, PB6.
Okay. That's why in my machine it has set up PB6 and PB7.
Yeah.
PB6 for TX and PB7 for
Okay.
RX.
Yeah. So just click on here and you can see USART1TX is available here. Select it. Okay.
Okay.
Now, another is USART1 RX. So I'll search here USART1 RX. And now again, two pins are getting blinked. One is PA10, which we have already selected here, and another is PB7. Just right click here and click USART1 RX. So either you can use PB6 and PB7, or you can use PA9 or PA10 for same USART1. Similarly, for any protocol, there are some optional pins available on your controller. You just need to find it like this using this search box. I think everyone understood it and we are good to go now.
Yes.
Yes, sir.
Yeah. So now our second thing is finding these PB6 and PB7 on our board. So for that purpose, we will just open our schematic and search PB6, correct? And you can see PB6 is available here on this IC, but we cannot use this pin because it's already connected with IC, where we need to find it on connector.
Chandan, what do you mean by connected to IC and then we are using the same pin for our use? So
Yeah,
what is the difference?
No, in the hardware of your controller, there are routing and layouts. It's like a way from one point to another point, how your signals are going.
Okay.
Okay, so this STM32 WBXX in QFN package, you can just use this IC. It's a very small IC. If you can show me your board, I'll tell you where it's located.
Okay.
Yeah, just so there, just on that white part which is getting upside.
This one?
Yes, this one. This one is QFN IC. If you will remove that outer package, it might corrupt your board, but you can see the QFN package installed inside that. So it's just this small part. So in your custom board, when you have to use STM32 IC, you don't need that much Nucleo board which you are having in your hand. Just that small part which you have just shown on the screen. This will be able to do everything that your STM Nucleo board is doing right now.
Okay, got it.
Yeah, for that purpose, it's connected there. But as we are using Nucleo board and we want to demonstrate, so we will use this pin on connector. So we will find it not here.
But when we are using that microcontroller, like custom boards, we can use direct on pin, right?
Yeah. There you can just direct select on your controller and directly without any connection you can just use it because it's already done by your PCB designer.
Yes, but I think Chandan, we have to give this information to the PCB designer that
the PCB designer already know it because he will follow this schematic only.
No, but we have to tell them that we are using PB6 for this use case. So you have to put the endpoint of PB6 at this place.
In in actual scenario in industry also where we are working, whenever PCB designer designs a PCB, he will collaborate with you like any software developer. Then he will read all the data sheet and everything schematic and all, and he will tell you that I am going to use UART on PB6 and PB7. Just confirm from your CubeIDE, will you be fine with it or I need to change it?
Got it. Okay, fine.
And with collaboration of both software and hardware engineer, these custom boards are made.
Got it. Okay, thank you.
Okay. So here you can see it's available on CN7 also.
PB6 on CN7. Okay.
Yeah, here PB6 on CN7, but here it's open. And in last class, what I have told you about open and closed circuit.
Yes, I think we have to put the resistor.
Yeah, so we cannot use this also because it's open. If we can remove this SB16, then we can use it. But no issue, we will find somewhere else also. Yeah, here. On CN10 connector, you can see PB6 is here and it's closed. That means our signal will flow directly here without any interruption.
Okay, so why we haven't used open one, because in that we have to remove that resistor. Is that
Yeah.
the case?
Yes.
Okay.
Because in that it's not resistor. Register is denoted by R. It's something like switch or diode.
Got it. Okay. So we have to make it open.
Close. No,
Close.
it's already opened. So what's happening when you are
Got
filling
it.
water on pin 34? It's coming there, and then when it's finding open here, so all your water is getting emptied here. So nothing reaches on PB6.
So how to close it?
Just this open circuit switch, you just need to remove it, and then the layout will be closed.
But the question is, if it is open, then why it is mentioned on the...
It's mentioned on the schematic because if in any case you are not finding any closed loop on your book controller, then what will your hardware engineer do?
Got
He
it.
will just remove those. These are optionals for emergency case, and you can use it.
Got it. Okay. Thank you. Great.
Sir, hello? Sir?
Yeah.
Actually, what's the purpose of this open circuit in this place?
This this pin 34, you can see here 34 pin number.
Yes, sir.
Yeah, so here this pin can be used for two purposes, for pin PA1 also and PB6 also. You can see this pin 34 is coming here and it's getting divided into two pins.
Okay.
So it's for two purposes. If you want to use this 34 number pin for PA1,
I think it's 32. Chandar, it's 32.
38, 34, 32. Yeah, sorry. It's 32. So if you want to use this pin 32 for PA1, you can just keep your circuit as it is and you can use. And the same pin for other purpose, you can use for PB6 also. For that purpose, many pins are kept floating or kept open or closed.
Okay, sir, I understand. Thank you.
Okay, so just write it here. We are not going to use it right now, but we will need it later. On connector CN10, we are having PB6 on pin number 34.
Yes.
Do I need to repeat it? On connector CN10, we are having pin PB6 on 34 number. Am I clear? Everyone write it.
Yes.
Okay. And our second pin was PB7. Fine.
Yes.
On the same connector, you can see PB7 here. Here you can see PB7.
Yes, CN10
on
6 pin number.
Pin number 6, PB7 is there.
Okay. So PB7 is a receiver pin, right?
Yeah. So PB7 is RX pin and PB6 is TX pin. Fine.
Yes.
Now we can use UART in 3 modes: polling mode, DMA mode. Yeah.
In controller, you say that UART 1 RX have 2 option and 3 option in selecting a pin. Port B and port A, different. So we can use a one pin of RX from port A and second.
No.
Okay.
you should try that if you are using first option like PA9 and PA10, it's not depending on the port like A port or B port. No, your one pin can be from port A and the second pin can be from port B, but the options which are getting selected. So if your first pin is on PA1 and first option is showing PA1 and the other pin is in first option is showing PA2, then you should stick with your options. If you are using option 1, then you should use PA1, PA2. If you are sticking with option 2, then you should use PB2 and PB3. In rare case, yes, you can use like RX pin of first option and TX pin of second option, but this needs modification in your PCB. With some minor modification, you can use it also.
So Chandan, sticking to their default setting will help the PCB designer to design the board easily, right?
No, yeah, it will help them to design it
Because
easily.
if you go
But
out of the box, then they have to do some manual job.
No, they always try that their routing can be easiest. For example,
got it.
If you are, for example, you are living in your house, fine, everyone, and you need to visit some nearby market. So what's your job? Your job is to move from one point to another point.
Yes.
Now, if I will suggest you one way in which there are 8 to 9 turns, then you will reach to point B. And there is another way which is just going straight from one place to another place, which will be beneficial for you. The straighter one path or the path having 8 to 9 turns.
The straight one.
Yeah, so in routing also the hardware designer prefers the path which will be straighter one. So whenever they will get these options in their PCB, they will calculate and verify in their routing, and whichever path will be simpler, they will choose or stick to this one. Until unless the software developer told him that no, there is no option of selecting that pin.
So Chandan, the follow-up question is, so as an embedded software engineer, we first have to collaborate with the hardware guy. Is that the case?
For making any new R&D project or R&D custom board,
okay,
your hardware team will collaborate with your software team. Only then one product is getting launched.
You mean before writing a single line of code, we have to discuss with the hardware guy that how we architect these pins and project and all.
Yes, your project team will be there, project planner team, and they will do all these discussions. And then one man from software team, one man from hardware team, they all get selected, and they are getting assigned their tasks respectively.
Okay, that's the case. Okay, fine, great.
Okay, so let's move back to our topic. And here you can see we are having our NVIC setting. So UART we can use in 3 modes: polling mode, DMA mode, and interrupt mode. Why we use these 3 modes? The theory part is covered in our previous video. Just watch it on from our website. Here we are using interrupt mode because 99% we will use interrupt case. Its reason is also mentioned, so you can just watch that video. Then move to this parameter setting. Here you can see it's 115200. If you want, you can change it also, but I am just keeping it at default. Now we are good to go. We have selected our UART and its pin. Now just click here, device configuration toolcode generation. Everyone can see it.
Yes, sir.
Yes.
Yeah, so our project is already implemented here. We will move to this main.c, and here you can see here my UART is already in it here. That means my IOC generation was successful. Fine. This was our previous code. I'll just comment it out. Now, in UART, what we will do? We will transmit and we will receive. We will transmit from one point and we will receive from one board and receive from another board. Fine. So first we will try to use transmit function. So for transmit, we should make one buffer which will transmit the message that we want to transmit. Perfect. So just find here. You can see user code begin 0. Everyone can see it. So inside this, make your buffer. Why we are making our buffer here? Because in the selected place, if you will write your code, it will not get deleted when you will regenerate your IOC file. So I'll just take uint8t, and I think you must have covered basic C and C coding. So I need not tell you why we are using uint, int, char, everything. So we will use uint8t, and this is for transmission. So I'll give it name like tx buffer. Always make your code more readable. Like you can give it name like uint a, B, C, D, but whenever someone read your code, he will not understand why buffer A is used, B is used. So give meaningful names. So when I'm giving it tx buffer, when everyone will read this code and they will think, yeah, tx buffer, it will be used for transmission. Correct? Inside this buffer, I'll store anything that I want to transmit. So I'll write something like numbers. Perfect. You can use your names also here, like just inside this, you can write your name. That will also work. Am I clear? Any message that you want to transmit from your UART, just place it in this buffer. That message will get transmitted by using functions. Now, you want your message to be transmitted continuously, correct? So in this way, if you want anything to be done in your controller continuously, you should write your code in this section while one, because while one is always true and it will be done or debugged or run continuously. So my UART function will be here. So we are going to use HAL library. Just write HAL. Which protocol we are going to use?
UART.
So write UART. And for what purpose we are going to use this protocol? For transmission or receiving?
Transmission.
So write transmit and press Control space. You can see these three options are here. If you are using your UART in polling method, you will select first one. If you are using your UART in DMA method, you will select second one. And for interrupt, you will select third one. Now we are using UART 1.
Sir, please explain again the three options.
If you want to use your UART in polling method, you will select the first option that will appear. If you want to use in DMA, then you will use the option of HAL UART transmit DMA, and if you want to use it in interrupt, then select HAL UART transmit IT. IT means interrupt. Now in this place you will use address of your UART. So which UART I am using? UART 1. If you are using UART 2, 3, 4, anything, just write its address like address of HUART 1, HUART 2, 3, 4, anything. Now I have to transmit my data or receive my data? Transmit, and my data to be transmitted is stored in TX buffer here. You can see it. So here I will write TX buffer. And what will be the size of my data?
8.
So yeah, you can write it manually. It's not 8, it's 10.
Okay, sorry.
Okay. So you can write it manually, but better you should practice functions like size of. So what will happen in this case? Whatever will be the size of your buffer, it will be assigned here. So there is no chance of any manual error in the determining the size of your data. For example, if you are transmitting 10 letters and you have mentioned size 8 here, so what will happen? Only first 8 bytes will get transmitted and you will miss your 2 byte of data. So always use size of operator. So size of TX buffer. Fine.
Yes.
Now terminate it and I'll just give some delay. HAL delay of 1000. You can give delay of 100 also. Perfect. So now this code will transmit my data that is stored in TX buffer from my one board to another board using UART. Fine.
Sir, in my after the size of I write a turn RX buffer, and after that it's timeout option.
You should use TX buffer, no? You are storing your data to be transmitted in TX buffer.
Yes, sir. Problem is that after that as comma and time out. In your code, it's not.
Can you share your screen and let me see it?
Yes, sir. Fine. It's visible, sir?
Yeah, it's happening because you are not using UART transmit in interrupt mode. You are using UART transmit in polling mode. You can see here HAL UART transmit. So this will be used for polling mode. HAL UART transmit interrupt will be used for interrupt mode. Underscore transmit just press control space. Yeah, so the third option. Yes.
Yes, sir. Okay, sir. Right.
Okay, fine. Now you can stop your screens here. Fine. So you can see my code is built successfully with 0 errors and 0 warning. Fine. Everyone just let me know when you are done with this.
Yes.
Okay, so now what this code will do? This code will transmit data from one board to another board. But many of us have only one board, correct?
Yes.
So how can we see that my data is getting successfully transmitted or not on single board? For that purpose, we will use serial terminals. So just go to your Google or Chrome, anything, and type doclite download. Docklite is a serial terminal. You can use teraterm, real term, anything.
But I think Chandan, this Docklite is not working in Mac, I think.
I have no idea regarding Macs.
Because I have tried earlier.
But there are exe files for Mac also. Let me check.
Do we have any other option than this Docklite?
Yeah, you can use teraterm, real term. So here you can see Docklite software version 2.4 for Windows. Just click it and it will get downloaded for your Windows. I have already installed it. Just click it and it will get downloaded. And Hatim, I think Docklite is not available for MacBook because I'm not seeing any option for MacBook here.
Yes, I have just checked that Docklite is not available for Mac OS.
Yes.
So we need to use some alternative tool like serial tools or something like that.
Yeah, so you can use serial terminal, teraterm, real term. I'll just show you how you can download them. For
So
example,
it is showing serial tool software.
Yeah, so yeah, here you can see teraterm.
Teraterm.
Yeah.
Teraterm, okay.
And here teraterm download. And this one is also for Windows.
I think the serial is maybe available.
Yeah, so you can use serial term also. If it's serial term, I'll check once more.
Serial tool.
Serial tool. Okay, you can use it.
Yes.
Serial tool. It's so basically we have to use serial terminals for making our port, like USB port or anything that you connect with your laptop.
So Chandan, for example, if you want to connect this UART with our computer machine.
Yes.
So can we create it with a custom software? So how it work?
For that purpose, you need to develop this serial terminal also.
Okay.
Then your terminal will get connected. Or there are TTL IC.
TTL
transistors. Yes, transistor logic.
Okay.
So you can connect with this also. So for everyone using Windows, you can just go there and download Docklite. I'll show you how it will look. It will look like this. Everyone can see this Docklite. Open it. Once you will open it, there will be some pop-ups. Just cancel it. And from here you can connect. Fine. Anyone having any doubt till now? Hello?
No.
Yes.
Yes,
Okay.
I have one doubt.
Yes.
Yes, that our PC is connected to this STM board, right?
Yes.
But our this UART pins are like floating pins that we selected.
These are either pull up or pull down pins.
Yes, but it is not connected to USB, right?
Yes, but the controller which you are using, it have ST link also. and the point from where you are connecting it using USB, that will create ST link also, and that ST link will make one COM port for you.
But this what we selected, that PB6 and the PB7, the UART port is not
Yes.
connected to this ST link, right?
No, it's connected to this ST link. Every pins that is available on UART on this controller, all those pins will be connected to ST link. You can see in the schematic. Just search ST link. Yeah, here you can see USB ST link, USB MCU, and on this connector, all those pins will be connected. LED pins and apart. Also, you can see here also ST link is connected to these pins. Here also. So everywhere these ST links pin are connected on your controller. You can see it. So every UART pin that is available on your board, that will be connected to this ST link.
Okay.
Fine. You can see, yeah, here you can see UART2 and it's connected with ST link RX.
The UART2, right? We are selected UART1, right?
No, I'm just giving you an example. Similarly, UART1 will be also connected with ST link. Each UART pin that's available on your board, that will be connected with ST link. If your board is having ST link.
Okay, fine. Thank you.
Okay. Yeah. So we have written our code to transmit it. Hatim, have you downloaded the serial tool?
The serial tool is not working in the Mac. It is showing a security issue.
Okay. No problem. There is one more way how we can verify our transmission, that whether my transmitted data is getting transmitted.
So I think
or not.
we can connect the TX and RX pin.
Yes, I'm moving to that part also.
Okay.
So now we have transmitted our data, but how can we verify this data is getting transmitted or not? So we will write a code for receiving also. Okay. So similarly for receiving, we will make one buffer here, uint 8t rx. We are using this buffer for receiving, so I will name it rxbuff. And I want to store 10 bytes of data, so I will use 10 here. You can use any size here. Fine. Am I clear?
Yes.
Okay. So now we have created our Rx buffer. Now in this, you can see user code here that we want to receive our data whenever interrupt will be triggered. We don't want to receive our data every time. So we will not use receive function in this while one loop. If we want to receive our data continuously, then we will use it in while one loop. But we want that whenever some data is sent to my transmitter, only then we want to receive it. So we will use outside while here. Just write HAL UART. We want to receive this time. So receive control space, and you can see receive interrupt is here. Select UART1. You will store this data in RxBuff, and here size of RxBuff. Fine. Now, very important part. For transmission of every data, you just need to transmit it. But for any protocol like UART, SPI, I2C, when you want to receive your data, you need to make one callback function also. Callback function is something that will be called when your RX will receive something. So we make this callback function in this user code begin 4. And this callback function is void HAL UART. We are making receive callback, so RX. And when this function needs to be called, when my complete is called, so RX complete callback and I will make it handle type def. So UART handle type def HUART. Perfect. Inside this will be called when my UART data is received. Here also I will write the same code. HAL UART receive interrupt HUART1 RX buff and size of RX buff. Now I will just build my code, and you can see my code is built with 0 errors and 0 warning. Now what we will do to verify that whether my transmitted data have been successfully transmitted and getting received or not. So what we will do, I have already told you in this schematic to write down the pin numbers. Remember? That was available on CN10.
CN1034.
Yeah, so on pin number 34, we were having our RX pin, and pin number PB6, that is pin number 6, we are having our RX, and there we are having our TX.
Yes.
So what we will do, we will take one jumper wire and connect this PB6 with PB6 with PB7.
Yes.
Okay. So you are having your jumper wires with you?
Yes.
Just show everyone.
Okay. Let me connect. Green. CN34, right?
No, just show everyone how does this jumper wire looks like.
Okay. Am I visible?
Yes. So this is a jumper wire. This is used to connect one connector point to another connector point. Okay. So
female to female.
Yeah. So them CN10 connector on your controller.
CN10. Here is the CN10.
Remove this USB cable because static current will be there. Yeah, perfect. Okay, so if you will watch your controller carefully, you will find names written like CN8, CN9, CN10. So just find CN10 that's available on the right side. And Hatim, can you connect those two pins, RX and TX?
Okay,
pin number 34 and pin number 6.
CN1034.
Yes. Once again, I'll just check. Pin number 6 and pin number 34. Yes.
6. Yeah.
So right now our RX and TX pin are short. So whatever we will transmit from our TX pin, the same data will be received on our RX pin. Fine. So just debug the code or just run the code that I have written just now.
But I think for that I have to connect it HT-link wire.
Yeah. Now you will connect it. And place one breakpoint in that callback. I'll show you how this breakpoint is placed, so everyone can see this. So if my data is transmitted, so first I will place a breakpoint here on the transmit functions. For place a breakpoint, just move to this line and double click 2 times. You can see this breakpoint is here. Similarly, place one breakpoint in callback function, move to line here 273 and double click. One breakpoint is placed here. Now Hatim, just show this.
Okay. So one breakpoint is on receiving and one is on transmitting. Okay.
Yeah. One is in receiving callback and another is on transmission.
Okay, now I'm
just share your screen and run the code.
Okay. Okay, I'm sharing my screen. Is it visible?
Yes, it's visible.
Okay. So I'm
okay, your code is built with 0 errors. Just put that board on your table. No need to show it.
Right.
Okay.
Okay, so first let me delete this.
No need to delete these things. Just run this code on your main.c file. Using breakpoint, we can see it.
Okay, fine.
I'll show how this can be.
Okay, so first breakpoint is at this hole in it. Okay.
Okay.
Now the next breakpoint is
yeah. So your code have reached HAL UART transmit. Just place your cursor on TX buffer. Okay. So you can see I have transmitted 1, 2, 3, 4, 5, 6, 7, 8, 9. And in TX buffer, you can see 0 to 9 are already getting transmitted here. Everyone can see this?
0 to 7, sorry.
Okay, your buffer might have contain these things only.
Yes, I have taken 0 to 7.
Okay, fine. So everyone can see it in TX buffer. 0 to 7 is getting transmitted from here. I want acknowledgement from others. Okay, perfect. So Hatim, remove this breakpoint.
Should I go to next?
No, remove this breakpoint because it will be continuously getting transmitted.
Okay.
And now press continue. Okay, so have it reached in the callback function?
Yes.
So in RX buffer, initially we had nothing, but now everyone can see we have received 1, 0, 1, 2, 3, 4, 5, 6, 7. So the same thing that we transmitted from TX buffer, that is received in RX buffer, which means by sorting our RX and TX, we have successfully transmitted and received our data using UART. Okay, Hatim, thank you. Now you can turn off your screen presentation.
Okay.
So we everyone saw how we can transmit and receive data on the same board using sorting this wire using UART. If anyone have any doubt regarding this, you can ask right now.
Sir, can you explain a brief code?
Sorry?
Can you explain shortly? You write a code again.
Yes. So what we did, we took two buffer, one for receiving and one for transmitting. So in TX buffer, we store our data that is to be transmitted, and in RX buffer, we had no data because whatever we will receive, that will be stored here. Now, receive function that's not getting continuously called, so we will use this in this user code begin to icon. HAL UART receive interrupt, RX buffer, but transmission will be done continuously, so this will be inside while one loop. HAL UART transmit interrupt using TX buffer. Now for receiving, you need to make one callback function. In any protocol, you have to make it. So I made one callback function, and inside this also I received it using RX buffer. And we on the same controller, we connected our RX pin with TX pin, so that whatever that will be transmitted from TX pin, that will get received on RX pin. And after that, Hatim demonstrated how we have received same data that we transmitted.
Okay, sir.
Okay.
Hello, sir. Hello, sir.
Yes.
Particularly, why did we place that callback function program in that fourth part?
You can
Not
place
in
it. You can place it anywhere outside while one loop. After receiving, you can place your callback function anywhere. This function is get triggered when complete receiving of your function is completed.
Okay. Transmission and receiving completed, then we can.
Callback function is only for receiving, not for transmission.
Okay.
You can make callback function for transmit also, but that's not needed.
Chandan, I have one question that why we have written the whole UART receive IT before the while loop? Because the actual receiving is happening
Actual receiving was happening at that line only in user code begin 2 section. But receiving data will be shown or displayed only in the callback function, because whenever you will receive the complete data, that callback will be triggered.
So if we remove that line in code
So in background, this line will be available there, and your data will be received there, and it will be displayed in callback function. But it's good practice that you should not keep any part of your code to be happened in background, because bugs may come later.
Got it. So it is like we are initiating the
receiving in the user code 2 and completing our receiving in the callback function.
Okay, got it.
Okay. So class, if you have any doubt, you can ask.
Yes, that callback function was just a function, right? It was not any interrupt or nothing, right? Then how it was like having a priority?
The callback function is already available in your half library. I'll show you where you can find it. I have made this function because I know how it works. But if you don't want to write all these things, you can find it from their library also. In driver part. Yes. So here in HAL-UART.c, you can see this function is already here. Void HAL-UART RX complete callback. For TX half complete callback, there is also function. If you want, you can use it, but as I have already told, TX callback function is not needed. For complete callback of TX, function is already there.
Okay.
Well, similarly, all these functions are available in this library. I'll mention only those which functions are needed for you. But if you want to explore, you can just open this file and read all the function. Fine.
Yes.
Okay, so now we have covered UART in interrupt mode. In the videos that's available on our website, I have covered UART, the data to be transmitted on docklight also. So the data will be transmitted from our controller to docklight, and I have also sent data from docklight, and that data was received on our controller. And the UART in polling mode and DMA mode also I have covered. So I'll just request everyone to go on our website and check those videos. And if you have any doubt regarding UART transmission that's covered today or in those lectures, you can ask.